right, part 2 of simple dilution. So number 4, prepare 2 ounces of a 0.05% solution of merthiolate from a 3% stock solution. How many mils of stock solution are needed? So once again, simple dilution, we know that we're preparing. We have a quantity and a concentration. So that is what is desired. And we have a stock concentration. So we're looking for mils of stock. We're looking for our quantity of stock, which would be our Q1. So Q1 times our stock concentration, which would be 3%. And then we're going to set that equal to what we are desiring. So here we see we're preparing 2 ounces, but the question is going to be asking us for mils. So the first thing we need to do is convert these ounces into milliliters. So you should know by now that 1 ounce is 30 mils. So if we convert 2 ounces into mils, 2 times 30 would be 60 mils. So then that would be our desired quantity, or our Q2. So 60 milliliters times the concentration of a 0.05% solution here. So based on part 1 of the simple dilution lecture, you should be able to solve for Q1, and then you can solve for the amount of solvent that would be needed. And with that, you should be able to prepare the directions for this compound as well. All right, number 5. A physician orders 10 mils of a 15 microgram per mil dilution of a drug for a child. The stock medication is 50 micrograms per mil. How many mils of stock solution are needed? So this one looks a little bit different. We don't have percentage strengths here, okay? But let's look back at our rules. So remember, number 1, convert ratio strengths to percentages and make sure our units are the same and that everything is in metric measurements, okay? So if we look at this one, these are not in ratio strengths. So they're not in a ratio, so we really don't have to convert them into a percentage strength. They are in metric units. So micrograms per mil here, micrograms per mil here. They are the same units. So in this case, we do not have to convert these because they're metric and they are the same. So we're going to do the same process with our simple dilution equation, just plugging these in as they are, okay? So they're ordering 10 mils of a 15 microgram per mil solution, and in stock, we have a 50 microgram per mil strength. So once again, stock equal to desired. Well, the question's asking for mils of stock, so I know that I'm going to need to solve for my quantity of my stock, or my Q1. So the concentration of my stock, once again, was 50 microgram per mil, and we're going to set that equal to the order. So the quantity of 10 mils times the concentration of 15 microgram per mil. That way, when I solve for Q1, I divide by 50 micrograms per mil here. Same thing over here. Those units will cancel out, and I'll be left with milliliters, which is exactly what we are looking for Q1. So go ahead and solve for the amount of stock solution that you need. Based on that, you should be able to determine how much solvent will be needed, and then you can write the directions for that prescription as well. All right, so up until this point, we've just been looking at simple dilution. So where we were taking one strength and diluting it down with a solvent. Now we're going to talk about combining medications of different strengths, okay? So we're going to go through two processes of what we call alligation. So mixing two or more medications together to get a final percentage strength. So the first method that we're going to look at is alligation alternate, okay? This is used when we are combining two different percentage strengths to make a third strength somewhere in the middle of those two. So we're going to follow the same rules that we had. In this case, all strengths need to be converted to percentage strengths. We need to be using, once again, metric units and the same units. Okay, so the final strength of the mixture must lie somewhere between the strengths of the two components. So we refer to this method as the tic-tac-toe method, and that's because how we set these problems up is in the same format as a tic-tac-toe board. Now, this probably looks a little bit scary at first, but I promise once we get into an example, it is actually very simple, okay? So I'll come back to this. So let's look at this example. How many mils of 50% dextrose solution and how many mils of 5% dextrose solution are required to prepare 4,500 mils of a 10% solution, okay? So I want us to imagine what is going on here. We're going to have a bottle of a 50% solution and another bottle of a 5% solution. And we want to make a total of 4,500 mils of a 10% solution. So I think, especially for the visual learners, if you think about what's happening, makes it a little bit easier here. So we're going to combine an amount of each of these solutions to make a total of 4,500 mils of a 10% solution. Now the rule states that this strength of our final product has to lie somewhere between these two strengths, which it does. 10 is in between 5 and 50, so that can be done, okay? What we could never do is combine these together to make a percentage that would be higher than 50, or combine these together to make anything lower than 5, because that just would not make sense based on how much active ingredient is in each one of these, okay? So let's start with our problem here. We always start with a tic-tac-toe board here. So you only use this method when you have two strengths and you're trying to make a third one, okay? So step one, always record your highest percentage in the top left. So we have 50% here. Always record your lowest strength in the bottom left, which would be our 5. And then record what you are trying to make in the middle. So we want to make a 10% solution, okay? Now the next question, the next step, we are going to subtract diagonally, okay? So we're going to go this way and this way, okay? So first, 50 minus 10 gives us 40, and you do not need to write a percentage sign here, just leave that as 40. And then we're going to go this way. but we're never going to have a negative number, okay? So we're always going to take our middle minus our lower. So 10 minus 5 gives me 5 here. So what I have just solved for here is the amount of parts that we need for each of these solutions, okay? So I technically need 5 parts of this 50% solution, and I need 40 parts of my 5% solution, okay? So that's the ratio that we're going to combine. We're going to need 40 parts of this one to 5 parts, or sorry, 40 parts of the 5% to 5 parts of the 50% solution, okay? But I don't know what that means. I don't know how to determine parts, okay? Because we work in units of volume, which in this case, we're going to look for mils. How many mils of each of these do I need, okay? So the next step is to find out how many total parts we have. Well, 5 plus 40 would be 45 total parts. So we're going to put each of these over the 45 total parts. And then we're going to multiply each of these by the total volume that we are solving for here. So take each of these times 4,500 mils. And then we are going to solve, okay? So do your division part first. Leave that in your calculator, and then take that times 4,500. So if we take 5 divided by 45, leave that in your calculator, and then take that times 4,500. That gives me 499.9999 repeating. So basically 500 mils here. So that one was 500 mils. And then we're going to do the same thing here. So 40 divided by 45, leave that in your calculator. And then take that times 4,500, which gives me 3,999.999 repeating. So roughly 4,000 mils. Okay, so what that means is I need 500 mils of my 50% solution and 4,000 mils of my 5% solution. We're going to combine those together to make 4,500 mils of a 10% solution, okay? So 50%, we would take 500 mils from here. And from the 5%, 4,000 mils from here. That way you can visually see the two parts that we're adding to make a total of 4,500, okay? So we can write the directions for exactly what's happening here. So we would say add 500 mils of a 50% solution to 4,000 mils of a 5% solution to make 4,500 mils of a 10% solution, okay? So these two parts here, they should always equal your total volume. That's a good way to check to see if you've done that problem correctly. All right, so I'm going to skip on your worksheet to number 8. So number 8 says, prepare 100 mils of a 4% solution using a 1 to 10 solution and a 1 to 100 solution. All right, so remember the rules for alligation. We have to convert ratio strengths into percentage strengths before we can start in on our equation here, okay? So first, let's change this 1 to 10 to a percentage strength. So 1 to 10, we can write that as 1 over 10. That means there's 1 gram of active in every 10 mils of total solution. So we're going to change that into a percentage strength. Remember that percentage strength is always x over 100. So I can just set this equal to x over 100. So 100 divided by 10, that gives me 10. So that is a 10% solution. Now I'm going to do the same thing here for my 1 to 100. Well, this is already in an x over 100 format, right? So x has to be 1 here. 100 divided by 100 is just 1. So this is essentially a 1% solution. Now I can read my problem again. Prepare 100 mils of a 4% solution using a 10% and a 1% solution. So here's another example of alligation alternate, where we use that tic-tac-toe method because we're taking two percentages and we're trying to make one that is in the middle of those two. So let's go through this process again together. So start out with your tic-tac-toe board. Remember, the highest percentage strength always goes in the top left. So the highest one that we see is 10. Lowest one goes in the bottom left. So that would be R1. And then what we're trying to make goes in the middle. So we're trying to make a 4% solution. Now the next step is to subtract diagonally. So we'll go down this way. 10 minus 4 is 6. And then back the other way. Remember, you will never have a negative, so it's always the middle minus the lowest. 4 minus 1 is 3. Once again, that is the amount of parts of each solution that we would need. So we would need 3 parts of a 10% and 6 parts of a 1%. The next step is to find out how many total parts we would have. Well, 6 plus 3 is 9. So there would be 9 total parts. So we're going to put each of those over the amount of total that we see. And then the last step is to multiply each of those fractions by the final volume that we are trying to make. So we're trying to make 100 mils of our solution. So remember, always do your division part first. Keep that number in your calculator, then multiply by your volume. So 3 divided by 9, and then we're going to take that times 100. That gives me 33.3. I'm just rounding to the nearest tenth. 33.3 mils here. And then the same thing here. 6 divided by 9 times 100 gives me roughly 66.7 mils here. Now, how do I see if these are correct? Well, they need to add up to equal our total volume. 66.7 plus 33.3 does equal 100, so I know I'm on the right track. Now let's write the directions so we can understand what's happening here, okay? So we have 33.3 mils of a 10% solution and 66.7 mils of a 1% solution. We're going to combine those two together to make 100 mils of a 4% solution. So we're just going to write that out as directions to tell somebody how to make this compound. So add or combine 33.3 mils of a 10% epinephrine solution to 66.7 mils of a 1% epinephrine solution to make 100 mils of a 4% epinephrine solution. So just writing the directions for what I just solved here. Okay. So now with those two examples, I want you to go back and answer number 6 on the worksheet. So number 6, you're going to want to change this into milliliters first, because we're going to be solving for milliliters of each solution. But that one should be pretty similar to the last two that we've done. Don't forget to write your directions here for that one. And then also on number 7, this one is the same concept once again, except we are working with grams instead of mils because this is an ointment. So same exact concept. You're just going to be solving for the amount of grams of each instead of milliliters. Okay, remember gram is a unit of weight, mil is a unit of volume. So once again, set that up the same way. And then I would also like you to write the directions for that one as well. That will be part of the credit for this problem. So make sure you write that on there as well. And then once you have completed those, you will be ready to move on to the alligation medial lecture.